Hello everyone, a very warm welcome to Smile Kids channel. Today we're going to deal with the topic of real numbers class 10. We're going to discuss few very important questions. So without getting late, let's begin. Question number 1. State fundamental theorem of arithmetic. So the fundamental theorem of arithmetic states that, first let's understand this with an example. Let's suppose say I have 55. This is a composite number. Now what is a composite number and what are prime numbers? Composite numbers are those numbers which can have factors more than 2. But a prime number has only 2 factors, that is 1 and itself. For example, 2. 2 has only 2 factors, namely 1 and 2 itself. Let's suppose say 3. 3 has only 2 factors, 1 and 3 itself. So 2, 3, etc. are prime numbers. Now here we have 55. 55 is a composite number because it can be expressed as a product of primes. Like 55. We're going to prime factorize this. 5 times 11 and 11 times 1. So the prime factors of 55 are 5 and 11 respectively. That means a composite number can always be expressed in the product of primes. And that's what our fundamental theorem of arithmetic states. So the simple definition of the fundamental theorem of arithmetic would be every composite number can be expressed or factorized as a product of primes. And this factorization is unique apart from the order in which the prime factors occur. Let's recall what is fundamental theorem of arithmetic. It states that every composite number, let's suppose say 9, it is a composite number. It can be expressed in the product of primes as 3 times 3. Now 3 is a prime number, so every composite number can be expressed as the product of primes, and this factorization is unique apart from the order in which the prime factors occur. Express 5005 as a product of primes. That means we are going to factorize 5005. 5005. Now first let me do it with 5. 5 times 1, 0, 0, 1. Then I'm going to do it with 7. 7 times 1 is 7. 3 is left out. I'm going to do it with 4. 7 times 4 is 28. 2 is left out. So it's 21 right now. 7 times 3 is 21. Then we're going to take 11 right now. 11 times 1 is 11. Here 14 minus 11 will be 3, right? So 33 is left out right now. So 11 times 3 is 33. And we have arrived to 13 and we know that 13 is a prime number. So 13 times 1. Now 5005 can be expressed as 5 into 7 into 11 into 13. So what are the prime factors of 5005? They are 5, 7, 11 and 13. Question number 3. The HCF times LCM for the numbers 50 and 20. Now, in order to find the HCF and LCM of 50 and 20, we're going to first find out the prime factors of them. Right. So, 50, 2 times 25, then 5 times 5 and 5 times 1. So, the prime factors of 50 are, 50 can be expressed as 2 times 5 times 5. This can also be expressed as 5 times 5 is nothing but 5 square. So it can be written as 2 times 5 square. Then we're going to find out the prime factors of 20. So here we have 20, 2 times 10, 2 times 5 and 5 times 1. So 20 here can be written in the product of primes as 2 into 2 into 5, which means 2 square into 5. Now we're going to find out the HCF and LCM of these two numbers. So HCF and LCM. So HCF will be equal to the product of the lowest powers. Now in both the cases 2 and 5 is common, so I'm going to write 2 and 5. Now the number 2 in both the cases have different powers. In the first one it has 1 as its power, and in the second it has 2. Which is least? 1 is less than 2. So it's going to be 2 to the power of 1 times. Now we're going to take 5. In the first case 5 has a power of 2, and in the second case 5 has a power of 1. Which is least? 5 to the power of 1. Now 2 into 5, which is going to give you HCF as 10. So the HCF of 20 and 50 is 10. Now we are not done. We're going to find out the LCM. So LCM will be the product of the greatest powers. We know that 2 to the power 2 is greater than 2 to the power of 1. So we're going to take out 2 to the power of 2 into, we know that 5 to the power of 2 is greater than 5 to the power of 1. So it's going to be 5 to the power of 2. So 2 to the power of 2 into 5 to the power of 2, which is going to give us 4 times 25, which is 100. Right. So we got the HCF as 10 and LCM as 100. But wait, we are still not done. We have to find out the product of HCF and LCM. So we know that HCF is what? 10. And LCM is what? 100. So HCF into LCM will give you 1000. Therefore, the HCF times LCM of the numbers 50 and 20 is 1000. Moving ahead to question number 4, the sum or difference of a rational and an irrational number is. Let's consider our rational number to be 5. And let's consider our irrational number to be root 5. Now, 5 plus root 5 will be the sum, and 5 minus root 5 will be the difference. Now, we must always know that the sum or difference of a rational and an irrational number is always irrational. Let it be any number. Here we have 5 as a rational number and root 5 as the irrational number. Let it be either sum or difference of a rational and an irrational number of any. Let's suppose a rational can be 1, 2, 3, 4 and many. Irrational can be root 2, root 3, root 5, root 7, root 8. Now, the sum or difference of any rational and any rational number is always irrational. That means 5 plus root 5 will always be irrational. And what about 5 minus root 5? It is also irrational. Therefore, the sum or difference of a rational and an irrational number is always irrational. Prove that 3 plus 2 root 5 is irrational. For this, we're going to use a method called contradiction. Now, for 3 plus 2 root 5 to be proved as an irrational number, we're going to first assume that 3 plus 2 root 5 is a rational number. Right, so the first step of ours should be like this. Let us assume that 3 plus 2 root 5 is a rational number. Now, what is a rational number? We know that a rational number is a number which can be expressed in the form of P by Q, right? We can express it in the form of P by Q, where P and Q are integers and Q is not equal to 0. And that's what we call it as a rational number, right? Now, once we assumed that 3 plus 2 root 5 is a rational number, we know that 3 plus 2 root 5 can be written in the form of P by Q. So, let's write it. Hence, 3 plus 2 root 5 can be written as P by Q. This means in the next step I'm going to write it as 3 plus 2 root 5 is equal to P by Q. Now, in this particular 3 plus 2 root 5, we already know that root 5 is irrational. So, I'm going to make root 5 alone. That means 2 root 5 is equal to P by Q minus 3. I have just sent this plus 3 over my LHS to RHS. When this is happening, plus 3 will change into minus 3. Now, we're going to take out the LCM of this, right? So, 2 root 5 is equal to P minus 3Q upon Q. On taking LCM, we get this, isn't it? Now, the 2 we have on the LHS, we're going to take it to the RHS, right? So, it's going to give us, So, root 5 is equal to P minus 3Q upon 2Q. Because it is in multiplication on the LHS, when it comes to the RHS, it will divide. So, root 5 is equal to P minus 3Q by 2Q. Now, wait, what? We know that root 5 is a rational number, but it is being expressed in the form of P by Q. Now, therefore, P minus 3Q by 2Q is a rational number. But root 5 is irrational. Why did this happen? This is a contradiction. This contradiction has arisen due to the false assumption that 3 plus 2 root 5 is a rational number. Determine the values of P and Q so that prime factorization of 2520 is expressible as 2 cubed times 3 to the power of P into Q into 7. Now for that, we're going to first find out the prime factors of 2520. Now, 2520. 2 times 1, 2, 6, 0. 2 times 6, 3, 0. 2 times 3, 1, 5. Then 3 times 1, 0, 5. Then 3 times 3, 5, right? Now 5 times 7 and 7 times 1. Now what are the prime factors? 2 times 2 times 2 into 3 times in 3 into 5 times 7. Now, what is 2 times 2 into 2? It's nothing but 2 to the power of 3 into 3 times 3 is nothing but 3 to the power of 2 into 5 into 7. Now let's bring back this expression. So it is 2 cube into 3 to the power of p into q into 7. Now if we observe, the value of p turns out to be 2. So p is equal to 2 and the value of q turns out to be 5. So the value of q is 5. So what are the values of p and q? The values of p and q are 2 and 5 respectively. Moving ahead, check whether 6 to the power of n can end with the digit 0 for any natural number. Remember that for any natural number to end with 0, it should be like 2 times 5 whole to the power n. And in this case, any natural number can end with the digit 0. Why do I say so? Because here, let's suppose say 10 to the power of n. 10 to the power of n can be expressed as 2 into 5 whole to the power of n, and hence anything to the power of 10. Like let's suppose say 10 to the power of 2. It is 100 and it is ending with the digit 0. Let's say 10 to the power of 3. It's 1000. It's again ending with the digit 0. Why? That's because it can be expressed in the form of 2 into 5 whole to the power of n. Right. Now let's understand the case of 6 to the power of n. 6 to the power of n. It can be written as 2 times 3 whole to the power of n. Isn't it or not? But here we have 2 as its factor but not 5. In place of 5 we have 3, which is of no use. We must always have 2 and 5 as the factors of any number whole to the power of n, and that's when a number can end with the digit 0. But here 6 to the power of n can only be expressed as 2 times 3 whole to the power of n, which cannot end with the digit 0. Right, if 6 power n should end with the digit 0, then it definitely must have 5 as its factor. But it's not possible because the only prime factors in the factorization of 6 to the power of n are 2 and 3. And the fundamental theorem of arithmetic states that the prime factorization of a natural number is unique. Therefore, for no natural number n, 6 to the power of n ends with the digit 0. Explain why 11 times 13 times 15 times 17 plus 17 is a composite number. Now, simplify this expression. We get 36482. 36,482 on simplifying 11 times 13 times 15 times 17 plus 17, right? So, they're asking us to explain the number we arrived to. Why is it a composite number? So this is a composite number because it can be expressed in the product of primes. When you find out the prime factorization of this particular number, it can be expressed as a product of primes. Here the prime factors of 36,482 are 2 times 17 times 29 times 37. And all these are prime numbers. And according to the fundamental theorem of arithmetic, we know that every composite number can be expressed as the product of primes. Therefore, we can conclude that 11 times 13 times 17 times 15 plus 17 is a composite number. Now, the HCF and LCM of two numbers are 9 and 90 respectively. If one number is 18, find the other. Now, for us, the given data is, let's write it down. LCM of two numbers. We already know one number, isn't it? 18, x. We don't know the value of x, right? We don't know the other number. So the LCM of 18, x is 90. Whereas the HCF of 18, x turns out to be 9. Now, how are you going to find the other number? We know that HCF times LCM is equal to product of two numbers. Right, product of two numbers. HCF times LCM is equal to the product of two numbers. Now we know that HCF is what? 9 and LCM is what? 90 is equal to, we know the first number, that is 18, and we're going to find out the second number, that is x. Now x will be equal to 9 times 90 upon 18. Now 9 times 1 and 9 times 2. Will be left out with 90 by 2 is equal to x, and x will turn out to be 45. So the value of x is 45. Now what is x? X is the other number. We know that one number is 18. The HCF and LCM is already known. We have just applied HCF into LCM is equal to product of two numbers, and upon arriving to the value of x, x is nothing but the other number, that is 45. Here comes a word problem. On a morning walk, 3 persons step off together and their steps measure 40 centimeter, 42 centimeter and 45 centimeter respectively. What is the minimum distance each should walk so that each can cover the same distance in complete steps? Now the step measures of 3 persons are 40 centimeter, 42 and 45 centimeter, right? So the minimum distance each should walk so that each can cover the same distance in complete steps will be the LCM of 40, 42 and 45 centimeter, isn't it? So for this, you're going to find out the LCM of 40, 42 and 45. Now, to find the LCM, we must find out the prime factors of each, right? So the prime factors of 40, 42 and 45 are, the prime factors of 40 are 2 cube into 5 to the power of 1. For 42, we have 2 to the power of 1 into 3 to the power of 1 into 7 to the power of 1. Then for 45, we have 3 square into 5 to the power of 1. We know the prime factors now. We're going to just find out the LCM. So LCM will be equal to the product of greatest powers. We know that 2, 3, 5 and 7. So 2, 3, 5 and 7 are the numbers which are there. Right. Now the greatest powers. The highest power or the greatest power of 2 is 3, right? So 2 to the power of 3. Then for 3, the highest power is 2. And for 5, the highest power is 1. And same with the case of 7, the highest power is 1. Then 2 cube into 3 square into 5 into 7. That is 2 cube is 8, 3 square is 9 times 5 times 7. Now this is gonna result to you 2520 centimeters. Now what is the minimum distance each should walk? The minimum distance each should walk so that each can cover the same distance in complete steps is 2520 or 2520 centimeters. Here we go. We have reached an extreme end. Thank you. And before leaving, do not forget to subscribe our channel, Smiley Kids, and hit the bell icon for all the updates. Thank you.